Hello everyone, myself Rakesh Kormokar from Kojibar Government Engineering College. Currently I am studying in Electronics and Communication Engineering Department. Today I am going to explain you the classification of signal. The signals can classified in following category. Let's see. Continuous time and discrete time signals, analog and digital signals, periodic and aperiodic signals, energy and power signals, deterministic and random signals, odd and even signals. So let's see this classification one by one. So first is continuous time signal. If the signal is specified for every value in time, then it is known as the continuous time signal. Here you can see the example of continuous time signal. You can see over here for each value in the time, the signal has some finite value. On the other hand, discrete time signal. If the signal is specified only for discrete time instance, then it is called discrete time signal. You can see there between two values, many values are missing over here. And the next classification is analog signal. A signal whose amplitude can take any value in the continuous range in the is called analog signal. So you can see over here its amplitude can take any value over the y-axis, and a discrete time signal can also an analog signal. Other than digital signal, a signal whose amplitude can take only finite number of values is digital signal. Here you can see the example. Here amplitude can take only two different values on the at one time. So next classification, periodic signal. A signal which repeats itself after finite time t, then it is called periodic signal. After some time t, it repeats itself. So if we shift time signal by over one time period, then it also remains same. Another hand, non-periodic signal or aperiodic signal, a signal which not repeat itself after finite time period t, then it is called non-periodic signal. And the next classification is energy signal. In short, the signal which has a finite energy is known as the energy signal. You can see the example. So the equation of the energy of signal is easy, equal to integration minus infinity to infinity g square t dt. Here gt is the function of the signal, and you can see here the function of signal is 2 e to the power minus t by 2, and we put the equation over here. So put the value of gt equal to 2 e to the power minus t by 2, and we get the answer of 4 joule. And the next, power signal. The signal which has the finite power is known as the power signal. And you can see the example. Average power signal, equation of average power signal is Pg equal to limit t tends to infinity 1 by t integration minus t by 2 to t by 2 and g square t dt. So you can see here the signal is the periodic signal. So the time period of signal t is 2 seconds, and we put the value of time period here, and we get 1 by 3 watt. And the next is deterministic signal. A signal which physical description is known completely either in mathematical form is known as the deterministic signal. Example of sine wave, square wave, DC voltage signal, etc. And the next signal is random signal. The signal which is known only in terms of probabilistic description like mean, mean square value, and distribution is known as the random signal. Most of the noise signal in practical is a random signal, and the final signal is even signal. A signal xt or xn is said to be even signal if they satisfy the following equation: x minus t equal to xt and x minus n equal to xn. Here you can see the example of even signal like cos t. Here you can see the symmetry about the y-axis in the even signals, and the other hand odd signals. A signal xt or xn is said to be odd signal if they satisfy following equation: x minus t equal to minus xt and x minus n equal to minus xn. Example of sine wave. Here you cannot see the symmetry about the y-axis. And the final conclusion is classification of signals in signal system is fundamental concept that helps in understanding the properties and behavior of signals, and it is important for analyzing, processing, and manipulating in various engineering applications like communication system, control system, and signal processing. So this is the brief classification of different type of signals. I hope all the classification understand. Thank you. Thank you.